Hello everyone, welcome to Satya classes. Myself Raj Pandey, and guys, thank you so much for watching my videos. So in this video you are gonna learn about combination of error, the way of writing the error and the way of calculating the error. Do you understand? So I recommend you to watch the full video and you will be learning a lot from this video. So coming up next, let's start combination of error. Now my first question is, why do we combine error? There must be some basic criteria for combining the error. So why do we combine error? First question is, why is it so let me answer it quickly. And we do combination of error because there are many quantities in an experiment, and when you combine the quantities they are added with their error. So combination of error is important. So let's see. The first one is error of a sum or difference. We wrote here sum and difference simultaneously. The reason being, sum and difference error goes by the same process of adding and subtracting. Soon you will understand this. So let us begin. Suppose that we have a quantity z and it is the combination of other two quantities a and b, and the measurement of a is a plus delta a. I told this in my previous videos, and those videos are really required to understand this one. So the measured value of a is a plus delta a and measured value of b is b plus delta b. Do you understand why I am writing these values like this? Yes, of course, where a is the mean value and delta is the absolute value. Understand? This is absolute error, delta a. And in the previous lecture I told you that this one is the mean and this one is the absolute mean. So there is a single value, so we will not find the mean. Understand? So let us write it quickly in this form: a plus delta a added to b plus delta b. Now what about z? Z will also have the error and z will also be written in the form of z plus delta z, where is delta z is the absolute error of z. Understand? So let me combine it: a plus b plus delta a plus delta b, z plus delta z. Now look here, a plus b and a plus b is equal to z. So in the place of a plus b you can simply put z, can you? And then thereafter z plus delta z. Now two sides z you can cancel easily, then z delta z becomes delta a plus delta b. Do you understand? Okay, so this is the final value where two errors have been added. Now look here, you can write it as delta a plus minus plus minus. So you can change all the values, plus minus, and here also plus minus plus minus plus minus. Okay, so the final value will be looks like this: plus minus and then plus minus. Nothing to worry about this, but what value we are going to take is only delta z is equal to delta a plus delta b, since error are added. So let us move for the difference one. Soon I will give you the example and it will be more clear to you. So let us move to difference one. I am erasing this. Okay, a the measured value, b measured value will not change. The change will be of a minus sign. Understand? Z plus minus delta z. Again I am taking plus minus, nothing to worry about. A plus minus delta I, then put a minus, write it as b plus minus delta b. Done. Open the bracket along with the minus sign, so it becomes a minus b. And okay, now what about this plus minus and minus when is multiply? The multiply minus of with plus becomes minus, and minus of minus with plus, so plus minus will remain same, will remain unaffected. Understand? Plus minus delta I plus minus delta b, delta z plus minus delta. Now look here again, this value is equal to what? Z. This value is equal to z, so z will be cancel each other, and you will get what? This is the same result you obtained previously. Understand? Delta z is equal to delta a then plus delta b. This is the same result you obtained for the sum, and now this result is for difference. So now the time is to make the law. I am not making. When you add or subtract, two quantities, the result of the error is the sum of individual absolute error of the quantities. This law you can write in your copy, and it may be asked in your examination 1 or 2 marks. Okay, so move to the next. The next error is error of a product or quotient. So for the product we write as z is equal to a into b. Again, a has its measured value a plus delta a, and b has its measured value b plus delta b. So write it as a plus delta a. Now this time I am considering positive sign, nothing to worry about, error are added, so I am taking only positive sign. The significance of negative sign is also useful, because when you reduce error it goes up to that level, b plus delta b, and for z, z plus delta z. Multiply quickly. I am doing, you can do in your copy. Okay, now here you can see the two error having the small values have been multiplied. So when you multiply the value less than 1 to the value less than 1, it goes to below the individual value, means this value can be neglected. This value can be neglected because this is so small, so neglect it quickly. Now what left? Z plus delta z ab plus a delta b and plus delta a multiplied with b. Now one more step, divide the whole equation by z. So here we'll write z, and the value of z is ab, so we will divide it by ab. There will be no change because z is equal to ab, so divide it by ab. Okay, now here you can see ab can be cancels each other and becomes 1. Here z will cancel each other and becomes 1, so this becomes 1 plus delta z upon z is equal to 1 plus, you can cancel a and a, so remaining delta b by b, and here you can cancel b, so remaining delta a by a. Note down in your copy. 1 can be cancelled, so the left value is delta z upon z is equal to delta a, writing in this manner. A I am giving first priority. You know addition follows the commutative law. Now this is the final result. Delta z upon z is equal to delta a upon a plus delta b upon b. Now clearly see this result, and if you had seen my previous videos, you know what this value indicates. This value indicates relative error. Okay, and I told that relative error and percent relative error are most popular error, so that's why these errors are commonly used in your question. Understand? So move for the quotient, and I'm erasing it right now. Now deriving the quotient to obtain this formula, I don't think it is so much good. This is just wasting of time and nothing else. So write it as, because same goes with the quotient, nothing will change, it will not change the value. So the same thing you are going to obtain for when you divide a by b. Understand? Or even I can also comment this, when you divide b by a, because ultimately you are getting this result, and this result follows by positive sign, means addition, so there will not be any change. Done. In this case I am taking a and b, and in some other case you can take some other quantity. Understand? So b part has been done. Soon I will give you an example based on this. Okay, this one is the C part. Error in the case of measured quantity raised to the power. What happens when you are taking a quantity having some power, like z is equal to a square? So for finding the error in this quantity, first of all you need to do is write the error in their measured form. Okay, now you are experienced a bit. So solve the square. What you will get? A square plus delta a square and plus 2 times a into delta a. Now again divide by z. So for this I will divide by z, and for this there is a, so we'll divide by a square. Again I am telling z is equal to a square. A square. Understand? Now look at this value, delta a square. This is negligibly small value because you are squaring, and this is less than 1, so it becomes much lesser than 1. This z becomes 1 plus delta z by z. You can, this is written in this form, and you can write it as, if you don't know in case, look here, just z plus z and then delta z upon z. That's why z will cancel and becomes 1, delta z upon z, writing like this. Understand? Is equal to 1 plus, this value is neglected here, 2 times a, since a divide, and then 2 delta a upon a. Now 1 cancel each other, and this becomes delta z by z is equal to 2 times delta a upon a. Do you understand this? Look, here the power was 2, here the coefficient of the relative error is 2. Okay, is it surprising? Not surprising, because when we say it, 2 times the relative error. So let's make the law. Law is the power will be multiplied to the absolute error when you take a quantity raised to the power. Understand this? So simple. Now I am taking an example to make it clear about the error studied previously. So look here, this is the multiplication. So for multiplication, how to write the error? Because they have power, so this is the case of power. So x will be here and delta a upon a. This is the relative error and x is the coefficient. So you will like this. Then again, the two quantities are multiplied, but their error will be added. So put a plus sign, write it y, then delta b upon b. What about power? Power is here, and then you are dividing c. Again you are dividing, but you will have to add the error. Then put plus sign, z will be like this, and delta c upon c. So this is how the combination is done, and for this you will write as delta z upon z. This is the way of writing the error. Okay. Now move to some question part, some interesting questions, so that it will clear our concept. Now I am picking an example. A resistor has marking as 470 ohm, 10%. What will be the true value of the resistor? So in this case you are just have to calculate the true value of this resistor. So for calculating true value, you know about the 470 ohm resistor and 10% its error. So for finding the error, what is the 10% of 470? Yes, calculate it. 10% of 470, good, 47. So 47 ohm is the error. Now the way of writing the value of resistor is equal to 470 and put plus minus 47 ohm. Now this time you need to do that this value will be plus minus 47 ohm. Now subtract this value and add this value. The resistor will be in between these two values. So subtract it. 470 minus 47, and this is the resistor, and then thereafter 470 plus 47. Again this is the, now subtract it. So you will 4, 2, 3. Okay, these values are in ohm. What about this? Again add it, becomes 7, 1 and 5. So the value will fluctuate in between this. Understand? This is the significance of the error. Error can change the value. Look at these values. Means if you have some requirement of a particular value and the error is changing the value, so your requirement will not be fulfilled. In this case you need to minimize the error. Understand the significance of this question? Okay, so in the next 5 minutes you will be able to calculating the values of error. Now see this question. Calculate the fractional error delta x upon x if x is equals to a to the power n. Now the fractional error, do you understand this? Fractional error means what? Relative error. Yeah, of course, relative error is a fractional error. So fractional error are written as relative error. Now look at this number. This number is n. So are you feeling that n will comes over as I told earlier? Remember that? Okay, good. So you can write it as delta x upon x is equal to n times delta a upon a. That's it. Understand? It was so easy. Just this is a way of writing the error. Look, the power n, and this is the right now in the coefficient form. This is n is multiplying with delta a by a. Understand? Look at this question. You are really going to learn a lot from this question, because this question is combinedly packed. Okay, look at the expression, and you have to find the percentage error in the x. So for this, first of all, let's break it by our knowledge, the way of writing the error. So let's see. You will write it as delta x upon x. This is the relative error. Then we will convert this relative error into percentage error. Understand? This is the first step and percentage error will be the second step. So let's do it. Look at a cube. For a cube you will write it as 3 delta a upon a. This is the again relative error in a. Put a plus sign. Thereafter b cube. For the b cube you will write as 3, again 3 delta b by b. Put a plus sign, no matter it is in divisible form because error are adding. C delta c upon c and plus. What about the root? Yes, exactly, d to the power 1 by 2. This is what I want from you to answer me. Delta d upon d, and what will here? 1 by 2. Now if you multiply equation LHS and RHS with 100, what you will get? You will get percentage error in X. Okay, so let me do it. It's going easy. Are you understanding? Into 100, and the last one is lack of space, but no worry, I will write it as 100. Okay, now suppose in case these values are given to you. Which values? The percentage error are given to you. This and this, these are the percentage error I'm boxing right now. This one, this one. Now what else remaining? Remaining these coefficients. No coefficient, 1/2. So suppose that the given values are, this is 2%, this is 3%, this is 4%, this is 5%. So let's calculate the percent error, and you know how to write percent error. Delta x is equal to, multiply it, 3 into 2, 6%, plus 3 into 3, 9%, 4%, 2.5%. Now add them and you will have the answer. Add them and you will have the answer. 6 plus 9, 15, 15 plus 4, 19, 19 plus 2, 21, 21.5. Okay, now this is the percentage error. Now I hope I have enjoyed a lot with you. I hope that now you have understand the concept of calculating the relative error while the formula written in the combined form. Understand?